Good morning, ladies and gentlemen of Precalculus. During sixth period yesterday, this problem was solved, and this was done by Emily, I think. And what she did is she made a drawing first, and this drawing here was try to make an approximate drawing of what this looks like. And she found out the first thing, which was this angle here. Using law of sines, you have your known ratio is you have 30 opposite your sine of 49 degrees. That's 49 degrees. And then you solve for b, take the inverse sine, and then you can find the angle C, which is 42, angle C, which is 89.672 degrees right here. And so here you can find out what side C is using law of sines again, and get little c 42.34. Okay, so that's that one worked out. So let's go on to 11. Yeah. What is that? Do that one. 11. Is anybody having trouble setting this one up? Janie, you can set this one up okay? You okay on this one? Anybody having trouble? Justin, you okay on this one? Looks like everybody looks like they're productively involved. Okay, good job. Okay, we have a new slate of possible contestants today. Okay. Spinning around here. Okay, Becky. It's me, Becky. What do you think?
You want to do the inverse, the sine.
Okay, let's do inverse sine. Okay.
I'll do the inverse sine and then 9 sine. sine 70, and then 14 on the bottom, over 4.
And what's that going to be equal to?
37.163 degrees.
So that's going to be
Be big C.
angle C, right?
Yeah.
So you said how many? 37 point?
37.163 degrees.
So that's angle C, okay?
Yes, and then angle A is 72.837.
So-
72,
So angle A is,
70, I took 72.837.
and you got that by subtracting
Yes.
70 and 30. Okay, yeah, that
Yeah.
makes sense. Okay, great.
Haven't got A yet, what A is.
So you're working on A?
Yes.
Okay, let me try to set up an equation for that. And I'll set up an equation, you tell me if that's right or not. I appreciate this, is really good work, Becky. Thank you. So we have, so is this your equation right here? Should be, that's the only one I can think of.
Yes, and I got 14.235.
14.235.
Yeah.
So we got angle C, angle A, and side A. Okay? Questions on that? Okay? That looks like some good work to me. Okay, thank you for doing that. Good work. Let's go ahead and work out number 12. Here we go.
So, 14.235.
Yeah, pretty good work. Talking to the sixth period class, some of the people in sixth period class say they remember law of sines from geometry a little bit, faintly. So that's what they said.
Sine 103. Yeah. They, I got 20 anything, or
Ronnie, you pretty
middle
well
A?
Yeah, I finished it.
finished it? You
31, 0,
almost finished it?
Oh, that's, yeah. That was, makes me move it, yeah. I'm gonna start, no problem, I didn't see anything to do this one after
Okay.
without working it all out.
Oh, really? Okay. So, I mean, if you do that, that's good,
Yeah, that was-
especially in the test, but you gotta be
Yeah.
careful.
Yeah, I'm paying attention to the
Just
numbers.
be careful because sometimes if you draw it out, it helps you avoid mistake. Okay.
I understand with everything.
Let's see, everybody's ready, but let's go see. Ready enough.
You take, you do A over sine 29.712.
Okay, this one is Riley.
No, this one's sine. That's over A. Equals 69 over, no, 69, I'm sorry, 43.
So I started off with
Okay, go ahead.
sine 103 degrees over 61
Okay,
equals sine B over 46.
sine B over 46, okay.
And to find the B, it's inverse sine 46 sine over 103.
Sine 103, okay.
Over 61.
Over 61, okay.
And then when you put that into the calculator, it gives you,
Angle B is,
wait, 47.288.
288 degrees, okay. Okay,
And then if you subtract out, or if you add that to 103 and then subtract it from 180, it
Okay.
gives you A, which is 29.712.
okay, let me go ahead. I'm just gonna write it up here the way you told me. So 103 plus 47.288. So A is equal to, you say,
29.712.
so 12 degrees, okay. Then,
And then if you do sine 103 over 61,
equals
equals sine 29.712 degrees
712 degrees
over A,
over A,
little a.
little a. Thank you for correcting me on that. Okay, little a.
Little a is 31.029.
Okay, so we got little a, we got angle B, and we got angle A. Does that look right?
Yes.
Okay, good work. Now what I want you to do is really pay close attention because we just have 25 and 26 left, right? And I want you to pay close attention to this. And Karina talked to me about this, was it yesterday, I think it was a little bit. Okay. Let me erase this for the next class. That's what I gotta do for this class. Get ready for 6th period as I go. Okay. So really, really 25 and 26 have a part A and a part B. So decide whether each triangle can be solved using law of sines. If so, solve it. If not, explain why not. So I'm going to go ahead and choose somebody to answer, let me say, 20, 25. Yeah, whoever I call can answer 25 A and B, right? So I will do that, I hope. I hope you will do that. I've got a few people here. Okay, we got, looks like it's going to be Robert or Jana. Robert or Jana, it's Robert. Okay, Robert, what do you think? First 25A, can it be solved using law of sines?
The one on the left hand.
One on the left can. Then it says, if so, solve it, right?
Yes.
So what do you have to solve using law of sines?
2 of something, like 2 sides.
Okay, you have to have a what? A known side opposite a known angle. A known side opposite a known angle. Is there a known side opposite a known angle here? Here's our known angle. Do we have a known side? We do not. Can this be solved using law of sines? No. Reason? No. Known side.
No opposite side. Would it be opposite then?
Side opposite a known angle. It has an opposite side, but they are not known, right? So you have to have a known side opposite a known angle. What about part B?
No, games
No, so this one here is what? Same, right? Same logic, we'll call it. Now, one thing I want you to do today is we're going to kind of park this over here, because this one here, A, we are going to be able to solve it today, but not using law of sines. So that's just a little tickler for what we're going to be talking about next. All right? Thank you, Robert. Now I'm going to choose somebody for this one too. 26. Okay. All right, let's go here. We're gonna have... Okay, Jana.
No, the first one you can, but you cannot.
So you say the first one can?
Yes.
Okay. Good, let me go ahead and mark it here. So you say yes, and then it says, and if so, solve it. So yes. What about this one here?
No, it was the same as for 25.
So no. And same logic as for 25. And then it says, if so, solve it. Have you solved this one yet?
Yes, so the missing angle is 32 degrees.
So angle B, right?
Yeah.
You say it's 32 degrees?
Yeah.
Okay.
And then I did 81 sine 20, 119 over sine 21.
Sine 119 over sine of 21,
29.
29 degrees. That's going to be,
Little c, which is equal to 146.128.
okay?
And then I did 81 sine 32
You want sine 32 over sine 21. And that's going to be A?
That's going to be
Oh, B, okay, because you have that unknown angle, B,
and
so
that's equal to 88.537.
537. Okay. And I want you just to hold your paper for a minute, because we are going to, in fact, I want you to get out your ACP formula chart.
Or you know,
You have it out? Okay, Robert has got it. Robert's on the phone. Okay, you have your ACP formula chart. Get it out, take a look at it. So you have your chart sheet, Justin? That's your chart? Good. Let me see if I have that up here. Get it up here. Here we are. Got it. And what I'm going to do is I'm going to erase parts of this just sort of to leave more working room, is what I'm going to do. And also here. And really on part B here, on 25B, there's no hope for it at all, because we don't have, you're going to have 3 elements of sides and angles at least to solve, and you you only have 2. So there's not really enough to work with there. Okay, let's go to look at our formula chart. Here it is. And what we have here is we have law of cosines. And what I like to do, the one I like to work with, and you have 3 separate equations for that based on different, for A, for little b, for little c. What I like to do is I like to make them all like this one right here on the right. That's the one I like to do. So we have c squared equals a squared plus b squared minus 2ab cosine c. What does that equation remind you of? Should remind you of something. It should remind you, I hope, of the most famous equation perhaps in mathematics. The Pythagorean Theorem. A squared plus, you said it, told me what it is. So what we have is we have a squared plus b squared equals c squared. And so that is, it's really the Pythagorean Theorem. And then this last part is right here, minus 2 ab cosine of big C. So this is little c here, and this is big C on the right. Okay, what does this negative 2ab cosine c do to this Pythagorean theorem? What do you think it does? Okay, let me put it to you another way. The Pythagorean theorem is a special case of the law of cosines. The Pythagorean theorem works when, okay, Pythagorean theorem, if I spelled that, that'd be nice. Okay, Pythagorean, and I'm just going to abbreviate Pythagorean theorem, works when cosine of C is equal to, what does this have, what does cosine C have to be for Pythagorean theorem to work? What does this thing have to, what does cosine C have to be for this thing to be 0? Zero factor property. What is, for this to be 0, what does cosine C have to be? It has to be 0. Thank you, Robert. When cosine C equals 0. And what is the angle for which cosine C equals 0? Cosine of what angle? Well, I'll tell you, you should know this from unit circle. Cosine of 90 degrees is equal to 0. And so for right angles, you don't need this at all, right? Which is what Pythagorean Theorem is. So what this 2AB cosine C does, it adjusts for angles other than 90 degrees. So if we want to find the side A over here, and what I like to do with these things here is I like to make them big C, little c. Okay, I like to just change things up just to make this. And so this could be side A and side B, whatever. So what we have is C squared. So I'm using this formula here. So C squared is equal to A, I'll call that A, and I'll call 19B. So we have 23 squared plus 19 squared minus 2 times 23 times 19 times cosine C, which is cosine 56 degrees. All right? Does that make sense? You have questions on that? Okay, and then the last thing I like to do, and you can write this on your ACP formula chart, this step here, is how can you solve for C? How can you solve for C? What can you do to this side on the right to solve for C? You can take square root. Yeah, thank you, Karina. So we have here, so what we have here is, I want you to put this somewhere in your ACP formula chart. Just put C equals A squared plus B squared minus 2AB cosine C. I want you to put that on your formula chart someplace. Okay, just to remind you. And one mistake that I see a lot of people make is I see a lot of people, what do you think I see a lot of people make a mistake of doing on these? Okay, what they do is they do this whole thing here, but forget to take the square root of it. And that's why I'm telling you to write it in, so you won't forget, right? So now we're gonna work this out. So we have C is equal to, okay, 23 squared plus 19 squared minus 2, 23, 19 cosine 56 degrees. All there under the radical. And the thing that's really good about this formula is I find that it's very easy to remember, to be able to do even without seeing it. So right now I can switch over to calculator mode. I have to remember 3 numbers, 23, 19, and 56, right? So I got to make sure, as Becky has told us many times in the past, we have to be in degrees if we're using degrees. Is that right, Becky? That is right. So we go here, and I'm going to press second alpha, and 23 squared plus 19 squared minus 2 times 23 times 19 times cosine 56 degrees. There we have. So that will be it. So 20.032, right? So C equals 20.032. And once you have that, you can use law of sines to solve for your other angles, right? Actually, you can use law of sines once And the last one you can solve by subtracting. So I'm not going to take time doing that. What I want you to do is go over to problem 26B and solve for side C. Can you do that? In fact, what I will do is I'm going to call on somebody to tell me what they did to solve, what they got for side C. How's that? And how they got it. Do you remember anything from 2 years ago in geometry about law of cosines?
I don't remember anything.
You don't remember anything about that? What about, Corinne, do you remember law of cosines at all? No, at all? Elizabeth? Justin, you don't, Justin? Okay. All right. For me, I'll tell you that law of cosines to me is simpler than law of sines. And I think, and why do you think that is for me? Why do you think it is for me? I have my own theory.
Because you already knew that thing, the whole idea.
Well, the reason is I think I connect it visually better to the Pythagorean Theorem. And so to me, it just... Now, another beautiful thing about law of cosines is that you can find an angle even if you don't have any angles. If you have just 3 sides, you can use law of cosines to solve for an unknown angle too. So we're going to do that also. So it looks like Karina is solving 26B, or you already solved it, right? Or she is solving it. Are you solving, Elizabeth? Everybody in 26? Call here. B. Okay, Elizabeth, you are it, Elizabeth.
You didn't choose the question.
Who are you with?
I was with JC and
I'm going to put the formula up here. C is equal to,
Who did you choose?
I chose, in art class.
You have to choose one.
okay. Do you have it, Elizabeth? You need help with that?
So I started off and I didn't put the numbers in, I didn't know.
So you should have 89 and 81, right?
I just put them in, I didn't know, I'll be maybe
Okay, yeah.
I still would have got the same answer.
Yeah, that's right. So you got 146.533, right?
Okay.
So Elizabeth got 146.533. So let's go ahead. I'm going to put this down here. First of all, before I even put in the figures that she used to calculate it, does this answer make sense? It kind of does. One thing you can do to kind of test, if you want to make an informal test, you could just do the Pythagorean Theorem, and you know that if you use a 90-degree angle, it's going to be less than what that answer is. But if you get C is equal to, and correct me if I'm wrong, Elizabeth, So you got 81 squared plus 89 squared minus 2 times 81, I think this is what I saw in Melissa's paper, times 89 times cosine 119 degrees. Is that it? Okay, so that should be it. All right? Are we good on this? Now, I was going to go ahead and start on the next little like preview thing, but I think we have a good stopping point today. We only have a couple minutes